just want to make sure that you're familiar with them, and that as you get into the book, you can see where they are. So again, in chapter 3, we looked at wind loads, snow loads. We looked at the uniformly distributed loads. We looked at some of the fire separations because of townhouses, and maybe if we have a garage attached to the house, how we have to separate that. We talked about the emergency egress windows, how to get out of a home in a bedroom situation where you're sleeping, you wake up, the house is on fire, you get out the window, and what the dimensions of that have to be. We talked about glazing and when it has to be tempered glazing, or where it's in a hazardous location, such as within 2 feet of a door, or when you have a big 9-foot painted glass that has the bottom edge less than 18 inches above a walking surface and the top edge more than 36, and there's a walking surface within 36 inches of it. You can fall through that glass. We don't want you to do that, so we make it tempered or have rails over it. We also talked about a bathtub or a hot tub, any place where it's slippery. We want that glass to be tempered. At the bottom of stairs and at the sides of stairs, if you could fall through it, we want that glass to be tempered also. So those sorts of things. We're in chapter 3. A lot of stuff in there about the type of wood that we use as far as pressure treated and decay resistant. Remember, we talked about those. The difference between them being that pressure treated wood is chemically treated to survive weathering and insects, whereas the decay resistant is already naturally able to resist those things, decay and probably insects as well, for at least a limited amount of time, right? Everything eventually decays. We talked about the height of those off the floor when we got over to, well, actually in that section, I believe, where we talked about if it's a girder or a joist, it can be, how many inches? Do you remember how many inches it can be down to the crawl space? If it's a drop girder or something underneath, we get 12 inches from the bottom of it down to grade. If it's a floor joist, it has to be up at 18 inches. And then the floor system itself, the subfloor, should be at least, I believe it says 24 inches. Or else it all has to be pressure treated, right, because it'd be too close to the grade. And the termites can build up mounds and get to that, and also it can rot. We talked about, what else in chapter 3? What do you remember from chapter 3? All right, well, chapter 4 then, what's chapter 4 about? One before that. Chapter 4 is about foundations and footings, right? Foundations and footings. And in that, you did the exercise where we tried to, or we did, figure out the size of the footings, the width and the thickness, also the projections on it, based on where it was as far as the county that it was in, the house size, number of stories, and the bearing capacity of the soil, right? When we found out what that soil was, it told us what the bearing capacity of it was. We put that into the chart based on how we were constructing the house, light frame or CMU or whatever. It told us what the width of that footing had to be. And then on the figures, on the tables, on the illustrations rather, it told us the rest of the information. How deep does the bottom of the footing have to be below grade? Minimum of 12 inches, right? And when we talk about the compressive strength of the concrete, we're worried about whether it's subject to weathering or not and where it's placed within that house. And that gives us, we get that compressive strength out of that table. We also have that, the bearing capacity of that soil, remember? So the two of them work in tandem. We're talking about the load that we're putting on the soil to make sure that the one will support the other. We also talked about in that section the foundations themselves, about what the drainage has to be around it. We also talked about the anchorage around it. Where do the anchor bolts have to be? How many inches from the corners? 12 inches from the corners, and every, how many feet thereafter? 6 feet thereafter. Half-inch bolts buried at least 7 inches embedded into the block or concrete. What else in chapter 4? That's about it. In chapter 5, we went to floor joists. And in chapter 5, because it's about floors and about framing, it starts talking about headers and girders, and so we have the header and girder chart in there as well. Remember, we talk about how many stories are supported, onto that girder, or how much of that house is supported by the header that's in the wall, and that gives us the span of it based on the load. or when we look at the span of it, we can determine how many members we need and what size they have to be based on the width of that span, length of that span. That's the header and girder table in chapter 5. Also in that table, it gives us the number of jacks underneath the headers when we have to place those in. But again, chapter 5 is really about floor framing. So we're talking about the length of the floor joists, or the span of those. And that could be from the wall to the girder, or all the way from wall to wall if they span all the way across, right? And how do we determine what that span is? We have to know what about the lumber? The species of lumber, the grade of the lumber, that's right, exactly. And then once we know those two things, we go into the table with our span, and then it tells us whether or not that size member can span that long, right? So once we figure that out, we know what size of floor joist that we need. Chapter 5, that was the headers and girders. Also, we talked about that. So then in chapter 6, we talked about wall construction. What size of studs we have to have based on how many stories that they're carrying and how long they are, but also the spacing of those, either 16 inches on center or 24 inches on center, that sort of thing. In chapter 6, because we start talking about connecting things now, we also have the fastening tables. Even though they're talking about, or fastening schedules, excuse me, even though they may be talking about fastening the roof down to the building, because we're in because they consolidated all in chapter 6, we have to go to there to see how many nails or how many staples or how many fasteners rather we're going to use to hold down those rafters, ceiling joists, floor joists, all those sorts of things that we're going to connect together, how we're going to put those wall studs together, all that sort of stuff. So now, the thing to remember about those tables is there are 3 different tables, right? We got the floor joists, we got the roof systems, then we got the wall systems, and then we have the floor systems, I think is the way that works. It gives you a picture and tells you what you're talking about, so once you see that picture, you can kind of know you're in the ballpark. That's chapter 6. Chapter 7 is wall coverings. Chapter 8 is roof and ceiling construction, and that's the same thing for the rafters we're talking about. For spans, it's the same thing, works the same way as the floor joists. We just look at what our species and grade of lumber is, and then we can see what the span has to be or what the size of the lumber has to be. Chapter 9 is roof coverings, where we talk about the different types of materials that we put on a roof. And when we're talking about putting shingles on, how many layers of shingles can we have on a roof before we have to tear them off? 2, only 2, that's right. When we go to the 3rd layer, or if we change to a different material, say you have asphalt shingles on and for some reason you want to put slate on there or clay tile or something, now you've got to tear off the old asphalt and build the roof new. Not only because of the shingles being a barrier there, but also being the weight of that roof. You're probably going to have to build it up for slate or for clay tile. It's heavier than asphalt, obviously. Chapter 10 is what? It's masonry in fireplaces. Remember, it gives us that beautiful drawing of the fireplace, cuts it in half, and then gives us a plan view, and then gives us the legend, which is a full page long, that has the alphabetized labels on it. And for whatever we're looking at on that fireplace, we just find the letter that corresponds to the part we're talking about, like the hearth or the hearth extensions or the smoke chamber, and then we take that letter to the legend, to that next page, and it tells us exactly what the dimensions have to be. Okay? Chapter 11 is energy, and when we talk about energy in residential, in this area we are zone 3, so what R value do we have to have in roofs? 30. R30 in the roofs. What's in the walls? R13. R13 in the walls, and then R what in the floors? 19 in the floors, right, exactly. So 30 in the roofs, 13 in the walls, 19 in the floors. And that's all we have to do in this area. We don't have to have any in the slab if we're a slab house, because it's we're in zone 3. Now, after we got through, that takes us all the way through the residential code. Who remembers how to get to the books after all these years, all this time we've been doing this? What's the magic letter? ICC or OSFM. We started at the very beginning, right? All the way there, it's going to take us under engineering codes. We can hit state building codes. It's going to take us here, and we can hit either code current and past, or we can hit over here. And that takes us to ICC. And we hit the state. Now, what I want you to remember when you come on here now, we're in the latter part of the year. First part of, the 1st of January, we start a new code. So they've already got the new codes loaded up. They want people to buy those. They've already sold out all the 12s they're going to sell probably. So you have to go over here to year and hit years, and now we're going down to 2012, all right? It's 2012 North Carolina code is what you want. And so once you hit it, you usually have to hit it again, and then they'll pop up. Now, you're gonna use 3 books when you take your exam, because we talked about 3 books during the course here. Which 3 are you using?
Commercial, residential.
Commercial, residential, and what's the third one?
Energy.
Huh? Administrative code, that's right, administrative code. So what do we get down in the administrative code? What did we do in the administrative code? Inspections, exactly. So what we have to do, if you go to the administrative code, chapter 1, what's the section number? Anybody remember that? 107. 107, it's really only 1 page long, or used to be, and then there's more commentary in it, so it takes 2 pages. On 107 in the North Carolina Administrative Code and Processes, these are the inspections. There are 8 of them. 8 inspections. And so if the question might be something like, what are you looking for on a rough-in inspection? So what would the answer be? Now, again, the questions are multiple choice. You're going to have your choices of A, B, C, or D. But when you come here, it tells you what those rough-in inspections have to have in them. And remember, the rough-in is really talking about the trades. It's talking about electrical, mechanical, plumbing, all that stuff that's going to be hidden behind the wall membrane once we get the insulation up and the wall membrane on, okay? That's the rough end. We're checking to make sure that all that is good before we cover it up, because after covered, obviously you can't see it. Nothing is more frustrating than having to take all that sheetrock back down to satisfy that stinking inspector that you didn't do exactly what you were supposed to do and you insulated it the way you were supposed to. Especially if you're in the midst of selling a house that you did the remodel on 7 or 8 years ago, and you can't show that you had inspections or permits on it. That's real fun. It's also fun to be the one to deliver that bad news. I hate to tell you this, but everything the best thing you can do for this is get a crowbar or a match. Now we don't feel it, say that. All right, so the building inspection, after all the trenches are excavated, everything's in the concrete, checking to make sure that it has that bare capacity that we talked about, and also that it is staked up and gives us the depth of that footing and thickness of it. Under slab, anything that's going to be concealed by the concrete itself, anything under that slab we have to look at if that's applicable. The foundation inspection, we look at the crawl space, and again, this is going to give you some commentary to help you know what to check on that foundation inspection. Rough ends, building framing inspection, and then we get to the insulation. After we do the framing, we can allow them to insulate, and then after the insulation, the only thing left in the residential is a final inspection. We don't do a fire protection inspection on residential construction. So it's really just a page or 2 in this book. And that's the administrative, administrative code. Now for the rest of them, or for the other part of this, we're going to go to the building code, right? The straight up building code, 2012, Blue Book. And you guys are such a blessed people, because this is the last time that I'll teach this class on this book, and this is the last time that you'll take a test on this book, and this may be the last time in your life that you ever see this book, because again, we're going to a new code come January, so that'll work. Now in this book, what we did was we also started the scope. We really started here before we did anything else. And this is where we talked about the detached 1 and 2 family dwellings. That's an exception to have to meet this code. 1 and 2 family dwellings, they go out to the residential code. Farm buildings, all that sort of stuff, they are not in our purview. We talked about what these little symbols mean too, when they've got the arrow means something's been moved, the underlining means something's by North Carolina, the line or the dark bar on the margin means that it has changed since the last code. You'll see when you get your 2018 North Carolina code books, it's based on the 2015 IBC. Our previous code was based on the 2009. There's a 6-year difference. It's not going to show you the differences between 9 and 12. It'll show you the differences between 12 and 15. So you need to catch up on all this stuff when you go into it to figure out what's all changed in those 6 years.
What's the
means that it's new from last code. So this one was a 2009, the one before it was a 2006. This language is new since last time. Or something in there has changed. Maybe as little as a comma or a letter or a rewording of a sentence, or maybe the whole paragraph. You know? The underline means that North Carolina made that change. I'm sorry? This one, the arrow means that something's been moved.
Okay, yeah.
Right, yeah, so you got the dark bar of the margin, something's changed, North Carolina language is underlined, and the arrow means something has moved or been deleted sometimes from the code. Chapter 2 gives us definitions. Now, the big thing I tell you in chapter 2 when we talk about definitions is what? The O.J. Simpson defense, right? If it don't fit, you must acquit. So if you look at that code section, and then you compare the definition of what it's talking about, and that definition doesn't fit, then that code section doesn't apply either, okay? So let's say, for example, you had a definition in there of a coat, what a coat was, and the code says it has to be made of nylon and has to be weatherproof. This is not nylon and it's not weatherproof, so this doesn't meet the definition that I just gave you for a coat. Therefore, any code requirements that we had that said coat don't apply to this, whatever pullover, whatever this is called. It's not a hoodie because it doesn't have a hood. So the language has to fit what you're talking about, or else the code section will fit, right? That's why we go back to those definitions when we have a question about that. We sometimes find that that's actually the case, that you can't make that definition fit, so you can't make the code section fit. Make sure you know the occupancies, use of occupancy classifications. There are 10, but within those 10, remember that we have the classifications themselves. So this is the use, this is the classification, the occupancy classification, A1, A2, A3, A4, A5, and then the others that have multiple ones in there. That would have been your homework assignment number 4, where you went through that list and it asked, or it gave you the function and asked you what the occupancy was. And yes, I know I still have a lot of those to grade, probably all of them. And then what we did after that, after chapter 3, when we knew what the occupancies were, we skipped chapter 4. Don't get bogged down in chapter 4, we didn't do it. And I'm not testing you on anything we didn't cover. Chapter 5 we went to, and then we did homework assignments 5 and 6. And in 5 and 6, what we did was a couple of things. It starts off actually with chapter 6 because it asks you what is that type of construction, and I gave you a little description of it, maybe some ratings, maybe not, maybe more of the description of the materials that were used, and then based on that you were to put all those clues together and deductive reasoning, figure out what that type of construction was, right? Types 1, 2, or let me say it better, types 1, A or B, type 2, A or B, type 3, A or B, type 4, which is heavy timber, or type 5, A or B. And remember, the A doesn't stand for anything, the B doesn't stand for anything, it's just to designate the difference between the two, all right? So type 1A has 3-hour ratings, type 1B 2-hour, type 2A 1 hour, and type 2B 0-hour ratings. We don't say it has no rating, we say it has 0-hour rating. Type 1 and 2 are non-combustible construction, concrete and steel. Right here, this dividing line, the rest of them on the other side of that line are combustible construction. Type 3, even though the exterior walls by definition are required to be non-combustible materials, because it allows down here the interior building elements to be of anything that's allowed by the code, and it allows fire retardant treated lumber to be used in the exterior walls where it's 2 hours or less, we consider it to be combustible construction. Fire retardant treated lumber is combustible. It will still support a flame. It will still burn. It's just fire retardant. Fire retardant means that it slows it down. Retard, slows, right? Fire resistant means that it resists that spread of fire for a certain amount of time. It resists it as long as it can. So when we're talking fire resistance, we're talking the ratings down here as far as those are concerned. Type 4 construction is the heavy timber. Remember, it has to meet certain sizes. What you'll find in this code is that it also includes the blue lambs, and it starts to talk about that wonderful new product we got called, well, it doesn't on this version of it. It does in the next version, the CLT. Actually, it goes to something called structural composite lumber, SCL, and it includes things like that cross-laminated timber we talked about. Remember those big chunky pieces that were cross-grained and put together? I told you it was just plywood on a bigger scale. Those also, in certain dimensions, will meet the requirements for heavy timber. And heavy timber basically gives us it shows 0-hour ratings in the column for the most part, but it is equitable to a 1-hour rating when we look at it on a code basis. Okay, so back up to the top here, you see heavy timber. It doesn't give us anything other than heavy timber. Right here, it requires exterior walls to be 2 hours or 1 hour, or heavy timber on the interior. And it doesn't really give us a rating for these, but we equate that basically to heavy timber. You can see that it's true when you look at one of these footnotes. Right, you see, in all occupancies, heavy timber shall be allowed where a 1 hour or less fire resistant rating is required. So based on the logic of footnote C, we can use heavy timber wherever a 1 hour rating is required, like in type, well, only in the combustible constructions, but like in type 5A. It's 1 hour ratings, and on 5B, it's 0-hour ratings. Again, this is what we call sticks and bricks. It's primarily studs and bricks that we put things together with, like a doctor's office, McDonald's, or a regular home or something. You don't need that has a lot of size to it. So we looked at the types of construction, and you did those in your homework. And then in 5 and 6, it asks you for that type of construction, and you would place that in there. Then the next column gives you a function of the space or of the use that we're talking about. And then you were to describe, or you were to assign a occupancy classification to that. So you would say it was like this room we said, remember, is, although it's set up as a classroom, the college is what type of use? Business, right? Business. Yeah. You're going to pay tuition again sometime soon if you hadn't already. You'll remember this is a business. So that's what we would classify it as. Then based on those two pieces of information, the type of construction and the occupancy, remember who's in the building, why are they in there, what are they doing? That's the occupancy. And then the construction of the building, what does the building add to the fuel load if the building catches on fire? Is it non-combustible or is it combustible? And if it's combustible, how much rating does it have on it? Has it got 2-hour rating, 1-hour rating, or 0-hour rating, meaning that it's readily combustible? And the more combustible it is, the shorter we want it and the smaller we want it, right? Because we want people to be able to get out on time. That's what the whole thing is based on, is egress time. How do we get out? Now, this is that table. In this current code, it's 503, it's 1 table. In the upcoming code, it is 3 tables. And what they've done is they've taken the height in feet and put it in 1 table. They've taken the number of stories and put that in another table, and they've taken the area and put that in another table. So you have each individual piece of information. But they've also gone ahead and done something we didn't do this time, and they have increased each of those for sprinklers. They put sprinklers in there and tell you what that would be if you added sprinklers. They've done the little math for you already. It's more confusing than it is helpful, but they figured we'd do that. So for example, if I had let's just go with this building. This building is a type B, is an occupancy B we talked about. The type of construction, we whittled it down one time and said this was supposed to be a 2A building, and let's just assume that it is a 2A building. So the maximum height of this building can be how much? 65 feet, and the maximum number of stories I can have is 5. And then for each floor, this is a 3-story building, each of those floors could be 37,500 square feet. Now, all of that's before any sprinklers are involved. If we add sprinklers, we can increase all that, but we didn't go over it, so don't worry about that part. We just wanted to make sure you could use the table, basic information. And I don't think any of you had any problems with that, but I still have the paper to make some mistakes. The next thing that we kind of mentioned very quickly, we go through all these modifications. We did talk about unlimited area buildings for a little bit. I showed you some of those. And we were saying that if we had these certain scenarios, for a non-sprinkler building that's an F2 or an S2, meaning a low hazard factory or a low hazard storage, if they're no more than 1 story in height, even though they're not sprinklered, they can be as big as that lot will allow them to be, as long as they have 60 feet open around them. And that 60 feet is to allow us to get around it and A, to make sure that fire doesn't jump over to other buildings, and B, to make sure we can get around it and fight the fire that it has. Remember, this is where we were talking about that big plant that I showed you back in the 50s where it was burnt. The next one is sprinkler 1 story. If it's a B, F, M, or S, or that's no more than 1 story above grade plane, or if it's an A4, which is an indoor stadium, an indoor stadium, of other than type 5 construction, then it can be unlimited in area as long as it's sprinkled with a 13 system. We talked about that very briefly. There's a 13 system. There's a 13R for residential, such as apartments and hotels and those sorts of things, condominiums. But then the 13 system's used on everything else. There's also a 13D, but it's rarely used in commercial because it's on the domestic water line. If you don't pay your water bill, you have no sprinklers because your water's cut off. That's why we don't use it. So anyway, the primary thing to remember here is on these unlimited buildings, the key point is whether or not it's sprinklered, what the occupancy is, and the 60 feet. That 60 feet is pretty much a constant for each of these scenarios. So even if it's a 2-story building, it's still requiring that 60 feet all the way around it. You can reduce that down to 45 on 3/4 of it, but on those walls where it's reduced down, those walls have to be 3-hour rated, including the openings, windows, doors, louvers, exhausts, anything that's open on that side has to be 3-hour rated. Never happens. It's too expensive. So, all right. So then after chapter 5, again, we have gone through a little bit of this mixed. Let me cover this again. Mixed use and occupancy. We talked about this a little bit, where the accessory occupancy can be up to 10% of the floor that it's on. Briefly spoke about this incidental accessory occupancies. If you have any one of these things, they have to be separated from the rest of the occupancies by what it says over here. So for example, I have an incinerator room. I'm at the bottom of a hospital that does surgery. They drop all these bloody organs into this incinerator room, right? You don't need that gallbladder anymore. It's no good. You can't use it. You can't put it in liver mush because you're not a pig. And you can't sell it to anybody because it's no good. So you put it in the incinerator. That incinerator has to be separated from the rest of the hospital by 2 hours and an automatic sprinkler system. So you have to have both. I was driving the back way out from my home where I used to live one day, and I came up the road and I had noticed this metal building had been there for years. Metal building had been there for years. But I noticed now there's this big chimney coming out of it. Big flue, big thing. And I'm wondering, what in the world are they doing in there now? You know, and you can see every once in a while when I'd come by there several times, you can see smoke coming out of it sometimes, but it wasn't running a lot. But one day, and I would see vans there at different times, you know, kind of unmarked vans or something. And one day, they messed up and they brought the company van and parked it out there. And the door was open a little bit, and I could see they were busy in there working, and I figured out what it was. It's a crematory. It was a funeral home that was bringing bodies out there in the cardboard boxes, sticking them in the furnace and burning them, and taking the ashes back to people. So you never know where those are going to pop up. Thankfully, it was on the downwind side of where my house was. But to be serious about that, and to put this in context, I have also been to. We were talking earlier about going to different places on the planet. I've been to Dachau twice, actually. Dachau is the very first concentration camp the Nazis put up. And when you ever see anything like that, especially the ovens and the sprinkler rooms where people were, it changes your life. It makes you different than what you were before. I encourage you to experience that if you can at some point in your life. Laundry rooms, all this sort of stuff that's added by North Carolina, all this in here could have smoke-resistant construction indoors, depending on what the size of it is. So you want to look at these to see if you have one of these incidental occupancies and to put it, to separate it as it requires here. Beyond that, the separation for any other occupancies that are trying to live together in the same building. We talked about this building, as a matter of fact, being a multitude of occupancies. Again, it's business where we're talking about the classroom areas. It is also business where they have the registration and where all the instructors' offices are, those sorts of things. But in this building, we also have labs, right? We got welding labs. We got different places where you work with materials. In the HVAC system or section over there, you work with refrigerants and with mechanical equipment to refrigeration and heating. Also, there is in the middle of the building, basically, there is the sign shop, which is actually an F1 occupancy because they have inks and dyes and things in there, and depends on how much of that ink and dye they have and what the materials are that they use, whether they're flammable or not. It could actually reach up to an H occupancy, but it's probably at F1. And the reason we call it that is because they come in with a raw product. They come in with the stickers or with the paper, and they make those labels that they make. They put the inks on them, they put the logos on them, and whatever. And when it comes out the other side, through that process, which is a key word, it's considered then that that's a factory. So let's say that we have that factory situation. We have the F1, and it's right next to some of the business offices in the building. And when we have that F1 and we have sprinklers, a 13 sprinkler system, meaning that it's a regular sprinkler system as it should be and not for residential. We have a 13 sprinkler system, then any separation between that F1 and that business has to be a 2-hour separation, okay? If it's not sprinkled, that is, if it has a 13R or any other type of system or no system, then that would be a 3-hour separation between them. So F1 to business would be a 3-hour separation. Now, 3-hour separation, you really get into the idea of these CMU walls or poured concrete. 2 hours you might get out of a shaft liner or a gypsum sort of product or cementitious, but you're not going to get that. You're going to get more than that out of the CMU block, so it's going to start costing more. So any questions about that? Everybody's got it. So y'all have already aced the test, so I'll jump into it, right? And we already went over chapter 6, talked about that. In chapter 7, what we did was we talked about those 5 types of walls. Anybody remember what those are? Firewalls, which separate one building into 2 or more. Every time we put up a firewall, we have separate buildings. Fire barrier is the second one, very good. That forms our shafts, forms our means of egress, like our stair enclosures, our exit passageways. It has several uses. It separates fire areas. So if we're going to talk about, for example, a strip shopping center, if we're going to sprinkle, if we're going to have a little restaurant in this strip shopping center, the restaurant may require sprinklers based on the size and based on the number of occupants by chapter 9, but the rest of the strip mall may not. So we could put in a fire barrier between the restaurant and everything else and just sprinkle that area. Theoretically, the city fire doesn't allow you to do that, but theoretically by code you could do that. So fire barriers, and then fire partitions are the weakest type of fire resistant rated wall that we have. And fire partitions really are for things, for specific items that are pointed out in the code. They're dwelling unit separations, so between apartments. They are sleeping unit separations, so between hotel rooms. That's where we're going to have fire partitions. There are tenant separations in a mall, so between the Gap and the Dollar Store or whatever else is in the mall, JCPenney. Those are going to be fire partitions. There are elevator lobbies. So anytime that we have an elevator lobby or a lobby around that elevator, that's going to be fire partitions. And they're also corridor walls. So like these corridors out here, those are fire partitions. They only have to protect us for the time that we're in the corridor. They don't have to stay up for 2 hours or 3 hours like an exit enclosure would have to do. An elevator lobby, by the way, is primarily, the reason we protect it is not because we're using them for egress necessarily. We can now with a special type of elevator, but it's to keep the smoke out. It's to keep us all, if that smoke gets in the hoistway, you keep it from going to floor to floor. That's what those fire partitions for. Yes, sir.
What if you're in an elevator shaft and you're already in a structure that's all concrete? Anyways, that's probably the most more compression concrete you can get, and you're already in an elevator shaft. How does that work? Because everything is already concrete.
Yeah, the shaft itself is required to be rated as a fire barrier from where it starts, from the foundation all the way up through the roof, or you have to cap it off. That enclosure itself, that hoistway, is rated. Now the way the shafts are rated, they're 1 hour if it's 3 stories or less. Anything that's 4 stories or more is rated 2 hours. It never has to go above 2 hours, even though it's in a high-rise building. It goes through 2-hour floors.
Well, what if your concrete structure is rated 3 hours?
Yeah.
How does that even, I mean, does that even, is that even necessary? Does that even?
It's not necessary. What can happen, you can have 3 hours, you can put more than what the code requires. Code's a minimum. Remember, it's a D-. So if you want to go for an A+, you can do that. You can put more on it, but we're not going to require it. And unless you meet all the criteria of section 3008 for an occupant evacuation elevator, you can't use that elevator for egressing, even though you're in a 3-hour shaft or 4-hour shaft or whatever, because the code doesn't allow it. It won't allow it until you meet all that criteria. Matter of fact, that's one of the last meetings I had this afternoon. That's why my brain's so fried. We were talking about how that. I told you this is only the 2nd occupant evacuation elevator in the country being put here in Charlotte. The other one's over in San Francisco, and we're trying to not only get it right, but we're trying to set the stage for everyone that comes after this, so that we make sure everything's in place and we get it right. It's a matter of if you're in this high-rise building and the fire alarm goes off or the smoke detectors go off, that elevator is going to respond to that floor that had the detectors go off, 2 floors below and 2 floors above, and that's the only floors it's going to go to. If you're on one of the other floors, that elevator's not going to stop for you. It's going to go right to those floors, get those people, and take them right down to the bottom because they're the most at risk. If you're on one of the other floors, you still got to go to the stairs.
Important question, how close do the egress stairway has to be? How far does the egress stairway have to be from the elevator?
That's very good. They can't be in the same, well, let me say it a different way. The exit enclosure and the elevator cannot be in the same shaft. As long as they're in 2 separate shafts, there is a fire service access elevator when you're over 14 stories, 10 stories. When you're over 10 stories, you have to put in a fire service access elevator so that firemen and firefighters can go up and get people and have control of those elevators. It has to be directly connected to an exit. So within the elevator lobby, you come out of the elevator, you're in the lobby, and then you go into the exit enclosure of the stair to get out, or vice versa, come upstairs, get whoever's in that elevator lobby and take them back down the stairs with you. In those cases, they're next to each other, but they're still in separate shafts to have separate protections. So then after that, we have the fire petitions, and then we have smoke barriers. And smoke barriers we're really going to find in our I occupancies, in the I2, which is our hospitals, our nursing homes, and then in the in I3s, which are jails or prisons, those sorts of places. And the reason for those smoke barriers is we want to contain that smoke while we protect population. So we're going to divide that building into these smoke compartments, and whenever something happens within a certain compartment, we'll move people out of that one and into the next one. So if this, for example, if we were out in the hallway and something happened and that was a smoke barrier, we would come on this side of it and we would be protected from that fire, from the smoke. And again, think about it, in the jails, we don't want to release people, right? In prisons, we don't want to let everybody go home because there's a fire. In the hospitals, we don't want to take people that have just had surgery or had, open heart surgery or in ICU or whatever. We don't want to take them out of the hospital. So what we're doing instead is we're taking them to a place of protection away from the event until we can get the event under control, and or if we have to, eventually exit them out of the building when things are safer or they're more stable or whatever. Now, once we get on the other side of the smoke barrier, we have to have an exit within 200 feet on this side. We don't go back across it to exit. We exit from our side.
So does that mean that there has to be another door within your space
Right.
to get out?
Right, there has to be a stair or something within this section for us to get out, so we don't go back across that. Yes, sir?
Any door that's painted red, does that mean anything?
No. There's no, the question was, if the door is painted red, does that have a meaning? In code, it doesn't. What really means anything to us, and you'll see it when you go to some of these doors. Matter of fact, I just took a couple pictures the other day, but I'll show you. I think I showed you this. I'll show you again. Major fire in a hospital, not in the United States. There has been in other places. There was a mental hospital in Russia about, 5, 6 years ago. It was in like an old home. It's 2 or 3 stories, and it burned and killed 72, 74 people because they couldn't get out.
Is the egress elevator,
Yeah, occupant egress elevator.
is that a higher occupancy, and is it a faster elevator?
It's a faster elevator because it responds to those areas where the fire is, and it also is more than one elevator. It's not just one. It's probably about 4 or 5 of them.
So they're used normally during the day, so they're just normal elevators with
Yeah, they're
different
regular
features.
elevators, but once the alarm goes off, the computer takes over and tells them where to go, what to do, that sort of thing. Well, I just looked this up here. Let me just do this thing. Yeah, what I wanted to show you tonight was a little bit of the egress stuff, and we'll get to that, but nothing seems to be at my fingertips when I want it to be. Now, this is what you're talking about, these kind of signs here, JD, but that's not really what we're looking at. We're looking at these labels. So when we've got a door that's labeled, or that's a fire door, it could look just exactly like that door and have no difference to it whatsoever. other than the label on the end of it. So on the top of it or on the back of the leaf, it's gonna have this label, say that UL certified, this one's a 3-hour door. The S means it's also smoke label. So this one can go in a smoke barrier because it's both fire and smoke resistant. And it tells you what standards it conforms to. And this temperature rise they're talking about is on the opposite side of the door, how hot the opposite side's gonna get. Did I show you the 3-hour door video?
Does the smoke barrier mean that there's a seal that will also?
Yeah, it means it was tested with a seal. Sometimes they tell you you don't have to install that seal when you install the door.
That doesn't make sense.
Yeah, it doesn't, but it meets the standard and, yeah. Come on, boomers. There it is. I showed you this one, right? You can see it again. What's happening here, and I think last time I had trouble with sound. That goes this time.
Yes. Yeah.
All right?
Yeah. It's like,
What does that mean? Like